Hey, top realized math industry, and we are gonna take a look at quadratics in real life. So recently, we've been doing a lot about the quadratic formula in the previous videos. But one thing that many teachers kinda may not do, or what many kids kinda forget to do, is understand, well, how can we apply the quadratic stuff in real life? So what we're going to do is solve a few problems here and there that is representing all the different work we've been doing in the past few videos. And we're going to see how does it really apply. So here's what happens. After t seconds, a ball tossed into the air goes from ground level, reaches at a height of h feet. So this isn't the entire question, because this is just giving us information that t is seconds and h is feet. And the function right here is the function of ht equals 144t minus 16t squared. We want to try to make it look like a standard form so we can easily understand what to do. So let's rearrange it so we can say negative 16t squared minus that by 100 plus by 144t. And that's going to equal ht equals all this. Let's take a look at the first question. So if we use that equation, what is the ball's height after 3 seconds? So it's giving us t as in seconds, and what we have to do is try to find what h represents if we put t into the variables right here as 3. Let's see what happens. So I rewrite the equation right here, and the problem literally did give us a value of 3. So since it's 3 seconds, we're trying to find out what the ball's height is. So we have to put 3 in for t right here and right here. So here's what's going to happen. When we insert these in here, we are going to get 3 squared is going to be 9. And then we have to do 16, multiply that by 9. We also have to do 144t, which is 3. So 144 times 3 is 432. And we also would have to do this. We have a negative 16 plus the 432. So, negative 16 times 9 is 144. Negative 144. Because a negative times a positive is a negative. So then we have to add that by 432. Our final answer is going to be 288 feet. That is going to be how high the ball goes when you throw it up in the air for 3 seconds. There's not really much physics involved. This is just the whole math part. So, if t was 3, then h represents 288. Now, let's try to look at the next problem. That one was a little bit easy because all you had to do is try to put 3 into the equation and then insert it in to find h. But now, here comes the next one. What happens if we try this one? What is the max height of the ball? So, the problem is, we don't really have any values given to us. All we have is that equation right over here. So, let's try to see what happens. So, I put another equation right over here. This time, it tells us that we need to understand what is the max height of the ball, which means we have to understand the t, which represents the seconds that happened over time, and also the h, the maximum height of the ball. We don't know either of them, so what we have to try to do is factor this equation and see what happens. If we find out t for both t's, we'll be able to know what has happened and how high has the ball flew. So what we have to try to do is, instead of solving the equation or trying to find like the y-x intercepts, what we could do is we're trying to find the maximum height of the ball, right? Yeah, we do not know our t, nor do we not know our h. But when we are playing with quadratics, there is something that we did learn in the past that will help us with this problem. Do you remember when we were doing quadratics, there would always be a point on the line where the quadratic would simply just end? We would also call this a min or a max. Yes, this right here, the dot that ends at the parabola, is called a vertex. So, in this case scenario, we're trying to find the maximum height of the ball. So, the vertex is going to have a maximum. The ball cannot go any higher than that, but below it. So, instead of the parabola looking like this, it's going to look like this, facing down on a graph. Infinitely down, but it's a maximum way up here. So, what we have to do is try to find the vertex of this problem. So, going back from the previous videos, we've learned that in order to find the vertex, we have to do x equals negative b divided by 2 times a. When we find out what our x value is, we'll be able to find out how many seconds in time, how many time in seconds have passed. But we still need to find out h. Whatever we got for x or whatever we got for t is going to be placed in for h. Here's what happens. So we have to do, here's our negative b, which is 144. So we have to do negative 144. Divide that by 2, multiply by the negative 16. When you add them all up, you're going to get 4.5. So that is going to be our t equals 4.5. But uh-oh, we're not done yet, because we still need to find the height way over here. We do know that the ball has had a flight time of 4.5 when it reaches its maximum height. But what is the maximum height? That's when we have to actually, just like last time, insert 4.5 into the t's to get our value for h. So here's what happens. Let's do the math. Negative 16 t squared plus 144t, 4.5 and 4.5. When you do 4.5 squared, you get 20.25. Negative 16, multiply that by 20.25, and we'll have to add that by 144 times 4.5 is going to equal 648. When you do the math all together using PEMDAS, what we will have is an answer of 324 feet. So when the ball flies 4.5 seconds upwards, it would have flown 325 feet. So we used t to find h. So that is another method where we have to use the maximum and find the vertex of where it is on the graph, and then we'll be able to find out how high the ball went. Use x to find y, and use x to find why this works. There is one more problem that we're going to take a look at. What is the time in seconds when the ball hits the ground? Well, in this problem, it's asking us what is the time in seconds when the ball hits the ground. Meaning, we have to find what the t value is. We don't have the h value, which we don't need, but we do need the t value, which we don't have. So, in this case scenario, we are going to have to factor this one out. And when I say factor, we have to find the fact of understanding what the time in seconds is. So let's see how we can do this. So, we have this right here. We can factor it to negative 16t, then t minus 9, and then equal that to 0. Because 16t, negative 16t times t is negative 16t squared. And negative 16t times negative 9 is going to be 144t. Because a negative times a negative is a positive. The one on the bottom is an expanded form of the one on the top. They're both equivalent. So here's what we have to do next. The zero product property. We have to do negative 16t equals 0. And then t minus 9 equals 0. They're just two separate equations. Divide by negative 16 and divide by negative 16. This is going to be t equals 0. When you have t equals 0, that means it can't work because when the ball flies up and down, it's not like it happened in 0 seconds. That's impossible. Meaning that we can get rid of this and it will not work. What about the other one? When we add by 9 and add this side by 9, our t is going to equal 9 seconds. And that's going to be our final answer. Because it makes sense because the ball goes up and down in a positive integer in seconds. Math can get very strange where it gives you more information than you think you need. And it also gives you more information than you require. But sometimes it is nice to know that stuff. But other times, sometimes you don't need it, but you only need just one of them. So that is how we can apply quadratics in real life. I hope this video has helped you understand the quadratics in real life. Thank you for watching Tao Ping Alliance Math Industry. Like and subscribe.